It's your friendly math tutor, Miss C here, and today we are solving this problem. So sometimes problems like this appear on tests in either the high school or college classrooms to see if students can transfer their knowledge. Sometimes they might appear on standardized tests like the SAT or ACT for the same reason. So if we read this problem, it says if 8 times the fourth root of 256x plus 9 equals 25, then what is the value of 3 times x to the negative 1? So ultimately, we are finding the value of this expression. But before we can do that, we have to figure out what the value of x is using this equation. So we're really being tested on, can we solve an equation that has multiple steps that's not super straightforward? And then can we plug it into an expression and deal with the negative exponent? So we've got this. So let's go ahead and work through how we would solve this. So I'm rewriting this here, and I'm going to write PEMDAS over here because we are going to be following the order of operations, working from PEMDAS from left to right because we are going to start by moving things across the equal sign. And just as a reminder, we do addition and subtraction together, multiplication and division together, and then we move through exponents and parentheses when solving equations. So when I look at this equation, there is nothing to simplify on the left side of the equation, which is why we're working PEMDAS backwards from the start. The addition and subtraction that I see is 9 is being added, so I'm going to subtract it from both sides. And that leaves me with 8 times the fourth root of 256x equals 16. All right, we're off to a great start. We're going to move on to multiplication and division. So I'm going to go ahead and I'm going to divide by 8. Remember, as our first step, and I should have said this earlier, we're trying to get the fourth root of 256x by itself because we need to get to that x, and the only way we can do that is by eliminating the root bar. So that's why we're trying to get that on its own side. So I'm going to continue dividing by 8 on both sides. When I do that, I have now successfully gotten 256, the fourth root of 256x on its own side. Now, technically, the fourth root is an exponent. So if you're tracking what we're doing with the order of operations, we're now on the E part of that. So to get rid of the fourth root, I'm going to raise this side to the power of 4 because the power of 4 undoes a fourth root. And I'm going to raise the other side of the equation to the power of 4 because in math, what we do to one side of the equation, we do to the other. Once I do that, I'm left with 256x equals 2 to the power of 4, which is 16. Now I'm starting PEMDAS over again, and I notice that my only operation here is multiplication. So to get rid of that 256 on this side, I'm dividing by 256 on the other side, on both sides. So when I do that, this makes a 1. I end up with x equals 1 over 16. If you put that into your calculator, that's what you get. All right. Now that we know the value of x, we can come back up here and we can go ahead and plug in x, which was 1 over 16 here. So we just did this substitution here. We found x and we plugged it in. All right, make sure that when you plug it in, you use parentheses because that power of negative 1 is being applied to the entire fraction. And what I know about negative exponents is this turns this into 3 times 16. So remember, the power of a negative changes the location of the values in a fraction. So in this case, 16 is in the denominator, so it moves it to the numerator, and it moves the 1 to the denominator. At any rate, that gives me 3 times 16, which is 48. So when we have 8 times 4, or the fourth root of 256x plus 9 equals 25, and then we find the value of 3x to the negative 1, that value is 48. All right, if you found this video helpful, please like it so other people will see it, and make sure to subscribe so you don't miss another math video. Till next time, remember, you've got